Today, I'm going to show you how I created some simple, spooky Halloween window projections. The first thing we want to do is determine the best location for us to projection map onto. We want to find a window that is large enough to showcase our projection content to be visible from far away. Additionally, it is helpful to choose a window that is easily accessible from inside the house. In my case, the house I'm using to projection map has two windows upstairs that are large enough to be seen from the street. The window on the left measures 5 feet wide and 6 feet tall, and the window on the right is 5 feet wide and 4 feet tall. Make sure you measure the dimensions of the window because you'll be needing this later to calculate the surface resolution. In order to accomplish this projection design, we are going to be using a technique called rear projection. Unlike you might see in a movie theater, rear projection is when we place the projector behind the screen instead of in front of it. This, however, causes a couple of problems that we need to be aware of. Traditional projector screens are designed not to let any light through. This makes sense because when you do front projection, we want all of the light that bounces off the screen to end up going back into the viewer's eyes. Also, since the projector beam has to pass through the material, some brightness is lost. Thankfully, there are special screens made just for rear projection, and you can pick these up at many different online retailers. Unfortunately, they can be expensive and bulky. Also, rear projection screens are normally come in a 16:9 aspect ratio, and it is highly unlikely that the windows in our house are going to line up perfectly with the screen. Because of this, I decided to go with a different approach and use some plastic tablecloths. This is one time I went onto Amazon and purposely looked for a cheap product that had negative reviews. I found this 4-pack of tablecloths that had complaints that it was too thin. While that would make a tablecloth bad for being used as a tablecloth, it is good news for us because we want the light to pass all the way through. Also, cheap plastic tablecloths are great because they're easy to install and dispose of after you are done. I simply used gaff tape to tape the corners of the tablecloth to the corners of the window, making sure to pull it taut so it would not move and remove any wrinkles. One of my windows was larger than the tablecloth was, so I had to overlap them in the center. If possible, get a tablecloth that is large enough to cover the entire window, or else you might have a very faint seam in the middle. Now it's time to tackle the system. I ended up using one projector for each window, particularly because they were in different rooms of the house. If you have multiple small windows that are close to each other, you might be able to get away with using one projector to cover multiple windows. I went ahead and I set up my projectors and connected them back to my computer using HDMI cables. Now that we have the projector set up, it's time to think about content. Since I only had a couple of days to get everything up and running, I decided to do a simple projection design. I used the MO2 plugin within Final Cut Pro, along with the Halloween Objects Pack to create 3-dimensional Halloween-shaped particles, and exported those with a transparent background. Next, I used Apple Motion to create various backgrounds such as caustics, rain, and fog. Now the fun part begins with the actual projection mapping process and getting to see our content in our windows. Using the dimensions of the windows we wrote down earlier, we need to calculate the surface resolution. We will be doing this by finding the ratio of the width to the height and multiplying the resolution of one axis by that ratio. I created an entire video on this topic, so feel free to check out this video here if you need a quick refresher. Since this is a simple projection design, I will be using QLab. We need to create one surface per window that we want to projection map onto. Then we will use the resolution we calculated before. Lastly, we need to go through the projection mapping corner pinning to map the surface to the window. Check out this video where I explain how to do this step by step. Now let's go ahead and drop our projection content we created into QLab. Since the backgrounds and particles were rendered out separately, we are able to layer them within QLab. And with that, we have created some simple spooky Halloween projections for our windows. If you found this video useful, feel free to give it a thumbs up and consider subscribing to support the channel. And I will see you next time.